Okay, today I'm going to talk about one of the most commonly used items that a mud engineer ever uses. Basically, it's called a Marsh funnel and a measuring cup. This is for crude testing of viscosity, relative viscosity that is. And it was developed and invented by Dr. Marsh back around 1935 and has been used extensively ever since. The beauty of this instrument is that it is very simple to use and anyone can readily understand the principles here. Pure tap water takes 26 seconds, plus or minus a half a second, to flow out the bottom of the orifice or the cone here. Thicker fluid will take 35, 40 seconds, 45, 50 seconds, so on and so forth. So it's a relative viscosity against water. And of course water has a specific gravity of 1. The overall dimensions of the funnel, it's a little over 6 inches in diameter. There is a 12 mesh screen here that you pour your liquid through to get rocks and pebbles and things of that nature out of the way that would interfere with the opening at the bottom. There is no real correlation with this type of viscosity with rheology as measured with a viscometer or a rheometer. The main reason is that this is gravity fed, so if you have a denser fluid, it's going to flow out faster than if you have a, say, less dense fluid. That gets us in the realm of what's called kinematic viscosity, which is measured in centistokes. And typically, kinematic viscosity is, if you do the formulation, it's the centipoise reading divided by specific gravity. So you get into density considerations there, which you don't really consider when you're doing, or you don't consider so much when you're doing a regular rheometer, Couette style, with a rotating rotor and a bob attached to a bob shaft. So, as I say, this is a relative viscosity, and it works very well for what it does. Basically, you're looking for trend analysis. If you get 43 seconds, 47 seconds, 38 seconds, and all of a sudden you get 85 seconds, then you know something has changed in your fluid. You don't necessarily know what has changed or why that change was made, but you do know that something has changed in the fluid, so it's time to do something. Basically, you're timing how long it takes 1 quart of liquid as measured by your measuring cup here. There is a line here at the top that maybe you can see, and that is a 1 quart mark line, or 976 milliliters in metrics. And you measure, using the quart as a measuring device, you measure the time it takes to fill this cup up to the quart line. That is the end of the test as such. The opening for the bottom, the orifice open here, down here, is 2 inches by 0.185 inches. There is a metal insert in here. If this metal insert gets lost, you need to throw the funnel away and order another $20 Marsh funnel. Now, they're not expensive, but this is very important. This has to be of a set size. If you can, I don't know if you can see that, but there's an insert in the end of the funnel there. So it's important that that insert remain in place. At the end of the test, you want to report your results in seconds. And don't try to convert to centipoise or anything like that. In a previous life with another company that I worked for, we tried for about 5 years to correlate viscosity as measured in a funnel with viscosity as measured with a viscometer. You can't do it. You just absolutely cannot do it. People try to take the ratio. They say 43 seconds is to X as 26 seconds for water is to 1, specific gravity of 1, and you do the ratio out and you get a number. but then you put that in a rheometer and with the same fluid, and you'll get a different number. So they're really not correlatable. Again, this is just a relative viscosity, but for what it does, it works very well. And there are thousands of these that have been sold in the past, tens of thousands, probably hundreds of thousands. And its beauty is its simplicity. So what I'm going to do, I'm going to show you how this is run. I have a bucket of mud here, and this is a field mud that was supplied by one of our customers. So basically, you hold your finger over the orifice. It's usually good if you take your stopwatch off. You can use a stopwatch. Most people just use their regular wristwatch. And I will take my mud sample, I will pour it in here to the bottom of the screen, the bottom of the 12 mesh screen. That is 1,500 milliliters approximately. So I'm going to measure this 1,500 milliliters, how long it takes 976 of it to flow out into the measuring cup as measured by the cup. And that's all there is to the test. So I'm going to try to do this by myself. It's a little difficult. I hope I don't pour it all over the lab, but here goes. This is my cup. This is my bucket of mud. And all right, we're up to the bottom of the screen. Now, I'm going to put my cup in place, get my trusty stopwatch out, and get me a good marker, and go. So I'm now 10 seconds into it, 15 seconds, we're at 25 seconds, 35 seconds, 40, and stop. I got 43 seconds. 43 seconds for this particular water-based drilling fluid as supplied by a customer of ours. So basically that is all there is to the test. If I rerun this test, as I said before, and I get 40 seconds and 50 seconds, and all of a sudden I get 90 seconds, or I get 30 seconds or something like that, it's very out of the ordinary. Then it's time to start adding saxabentonite or lignosulfonate or something to the drilling mud to thicken it up or thin it out, whatever. So that basically is how you run a Marsh funnel viscometer test. It is very simple, very easy, and it works very well, and that's its beauty. That is its beauty. It's a very simplistic piece of equipment. Thank you very much.